Hi, this is Charles from Harvard USA. Welcome to the introduction to compile Yocto image in Amazon EC2. Just a reminder that we're gonna compile a Yocto image that's gonna be work on the Hio EMB 1200 Freescale IMX6 dual-core board, and that one gonna work for the 3.5-inch wall pad as well as the 10-inch panel PC. In Amazon EC2, we will boot up with Ubuntu and set up the Yocto environment. We will need to install the prerequisite tools and the Hio Yocto meta layers, which we call the Hio Yocto BPS. Also, we need to install the BigBake tool. BigBake is a build engine that follows recipe to execute tasks for cross-platform compilations. After we have set up the Yocto environment, we can start building our own Linux distribution. For this example, I'm going to build a frame buffer with Qt, SSH, and Wi-Fi driver. As you can see over here, different machines have different machine variable. Usually when you compile different images, you need to change the source, configuration, compilation build, and instruction, etc. But for Yocto, you only need to change the machine variable, and BigBake will choose the right configuration for you. After we have set up the environment, we're gonna have something like this. So the build x11 is where the BB layer and the local configurations are stored. After the compiling, we're gonna see the temp folder. Inside the temp folder, we're gonna see work, deploy, log, and a lot more files. The source folder is where we store the meta layer, the recipe file, and the tree structure on how to get the recipes. The download folder is where we store all the files that we get from the recipe instructions. So this is an example of the Hello World recipe, description, sections, license file check num. The MD5, the BigBake gonna check the MD5 of the file and the actual MD5 and see if they are matched. If they do not match, BigBake will return an error. PR is package revisions, the location of the file, the build directory. This line is gonna compile the Hello World C file and then output Hello World. For install, we're gonna create a directory called bin, and then we're gonna put Hello World into bin. BB layer tells BigBake where to locate the recipe of the application. For example, if we want to locate a Qt file recipe, we need to go to the Hio Yocto BPS, go to sources, and then we can see the metadata of the Qt file. The next file is local.conf. This file gives BigBake instruction on what to do. So for example, we specify the machine variable over here. We tell what package should be distributed, install extra images or features, and then if we want to install other application, we can also specify over here the number of threads and parallel make that BigBake can have, to download the application from the source mirror, and where to store the download files. These are all the files that we have after we have compiled the image. We're gonna have the U-boot, the kernel, and the root files. Usually we do not change the U-boot and the kernel much, but we change the root files a lot. The U-boot is for the bootloader, the kernel is for the tree structure files. The root file system right here is for the frame buffer. So we have the SSH, USB Wi-Fi, and the Qt frame buffer framework. In this terminal, I have connected to my Amazon EC2. In my home folder, I have set up a bin folder that contains repo, which is all the information of Yocto. Also, I have created a 120 gig drive and mount it to my Amazon instance to store my images. In there, I create a Hio Yocto BSP. This is where I store all the information of the Yocto environment. For example, if I want to build a fan buffer, I have to export the machine variable, which is imx6dl port, and then set up the environment. I'm gonna call it buildfb. In buildfb, you will see a configuration folder, and inside the configuration folder you will see the BB layer and the local configs. I have modified the BB layer and the local config to the same one in the PowerPoint presentations. So right now I can big bake the image, which is IO image FB. Then big bake will gather all the recipe in the source, and local config will tell big bake what to do, and then we're gonna compile the image from scratch. The compiling process usually takes 2 to 3 hours on regular computer with 4 cores, but for the Amazon EC2, this one I have the 36 core, so it's gonna take 20 minutes. It's really efficient to use Amazon to compile Yocto image. After you have finished compiling, you can go to the build directory and then go to temp, deploy, images, IO. In there you will see that the important deploy file, for example the kernel, the U-boot, and the root files. That's it for the part 2 of this video. For more information, you can visit wiki.hioproject.org. Thank you.